Okay, let's start with a chapter which is easy to understand, chemical kinetics. Before starting with this chapter, we should know what is a chemical reaction. A chemical reaction consists of two major components, the reactants and the products, separated by an arrow. The conditions for the reaction, such as what temperature, pressure, or what catalyst we are going to use for the reaction to happen, is written on the arrow. For example, let us take a reaction A plus B gives me C plus D. Here A and B are reactants, whereas C and D are products. The arrows on the arrow, I can represent the temperature, pressure, or catalyst, whatever required. Now, there are two aspects to study the reaction. Either you can study how is the reaction happening, or either you can study what are you getting at the end. It's like just knowing how tasty is the food made or how is the food made. There are two aspects. One involves learning the rate of the reaction, that is the mechanism, and the second involves knowing only the end products. Now, if I am consider only of the end product, that is what I am getting, I will be studying that part in thermodynamics. As of now, chemical kinetics, we study the rate of the reaction, that is the mechanism of how the reaction is taking place. To know rate mechanism, first we should know what is rate. In a layman's language, rate means change in something with respect to change in time. Okay, so what is rate? Rate is change in something, that's in layman's language, say change in something with respect to change in time. Now, what changes during chemical reaction? We know initially there is only reactant with us, whereas at the end we have only product. Now, this is for an irreversible reaction, that is a reaction in which the product does not get converted back into a reactant. So, for such reaction, concentration of the reactant decreases with respect to time, whereas concentration of product increases with respect to time. Let's take a more simpler and more detailed reaction. AA plus BB gives me CC plus DD, where small a, b, c and d represent the stoichiometric coefficient or the number which we write to balance the reaction. For this reaction, we know the reactant, that is A and B, will decrease with respect to time, and the amount of C and D will increase with respect to time. If I plot a graph of concentration of reactant with respect to time and a graph of concentration of product with respect to time, I see that concentration of reactant decreases with the increase in time, whereas concentration of product increases with the increase in time. Now, why does this happen? We know during chemical reaction, reactant react to form product. The main purpose of the reaction is to form the product. So, as soon as the reaction starts, the reactant keeps on disappearing and the products keeps on appearing. Right. So, it won't be wrong to say that during a chemical reaction, there is change in concentration with respect to change in time. This can be referred as a rate of a chemical reaction. So, what is rate of a chemical reaction? It is just change in concentration of the species with respect to change in time. Now, if you see, there is change in concentration of A, B, C and also in D. So rate can be more specifically for this reaction written as rate is equal to change in concentration of A upon change in time, can also be written as change in concentration of B upon change in time. Similarly, I can write with respect to D and with respect to C also. Okay, so is this clear? Rate is nothing but change in concentration upon change in time. Now, what are component of a reactant? Reaction, reactants and the product. Here the reactants are A, B and the products are C and D. Let us proceed to understand more. For the same reaction, that is AA plus BB gives you CC plus DD, we go in more detail about rate. So rate, let us take initially A1, B1, C1 and D1 are the concentration of A, B, C and D respectively. Now to represent concentration, I will indicate a square bracket. Here the square bracket means concentration. So now this is read as concentration of A, this is read as concentration of B, this will be read as concentration of C, whereas this will be read as concentration of D. Right. So let us take the initial concentration as A1, B1, C1 and D1 and final concentration as A2, B2, C2 and D2. Okay, from a time interval of T1 to T2. So for this reaction, I can represent rate as it will be final minus initial. Change is always given by, if I am writing change is always given by final minus initial. So I can write it as A2 minus A1, since A2 is the final concentration whereas A1 is the initial one, upon T2 minus T1. Again I am saying the square bracket to represent concentration. So this is read as concentration of A2 minus concentration of A1, which is also equal to concentration of B2 minus B1 upon T2 minus T1, can also be written as concentration of C2 minus C1 upon T2 minus T1, can also be written as T2 minus T1 upon T2 minus T1. Now the question arises, why are this equal? Concentration of A may not be equal to concentration of B. So why are this equal? See, the amount of reactant reacting will be corresponding to the amount of the product form. Right, so everything happens with respect to the balancing. Like for example, if this reaction requires 1A and 1B, okay, so that means when the reaction is taking place, 0.1 part of A will react with 0.1 part of B to give 0.1 part of C and 0.1 part of D. That is if the coefficient of are 1, 1, 1, 1 respectively. So the stoichiometric coefficient also take an important part here. So in order to balance it with respect to the stoichiometric coefficient, we divide it by their coefficient. So this is how it looks. Rate will be 1 upon A, change in concentration of A upon change in time. Similarly with B, C and D. Now change can be represented by either a triangle, that is delta, or I can represent it by D. Delta always represents bigger change. So if the time interval is more or if the change is more, we represent it by delta, whereas when I'm talking about a small change, we represent it by D. Now when are we going to use delta? When are we going to use D? Now for a chemist who is studying the rate of the reaction, he has to study every reaction in minute detail. For studying the reaction kinetics in minute detail, we need to know what is happening at every interval of seconds. So for that purpose, we won't be dealing with delta, we will be dealing with d, that is small change, because we need more accuracy, right? So let us represent the same equation in both the form, and then we write. So rate can be written as 1 upon a, I'm writing initially as the delta a, that is change in concentration of a upon change in time, which can also be written as 1 upon b, change in concentration of b upon change in time, also written as 1 upon c, change in concentration of c upon change in time, and change in concentration of d upon change in time. Now if you see, there's something missing. If you know that A and B are reacting, as the reaction proceeds, the amount of A and B will decrease. So if you see that A2 is smaller than A1, that means A2 minus A1 will be negative. Similarly, B2 minus B1 will be negative. So this will be recorrected as, or rewritten as, rate is equal to minus 1 upon A delta A by delta T, which can also be written as minus 1 upon B delta B by delta T. But for the product, it is not the condition. For the product, the concentration increase, that means C2 will be greater than C1, hence C2 minus C1 will be positive, hence it is 1 upon C delta C by delta T, and 1 upon D delta D by delta T. Okay, now if I am representing this equation by delta, that means the time interval is more. Okay, so for such thing, we call the rate as average rate. Now what is average rate? Like for example, I'm talking about average speed. I start a journey from say 1 kilometer to 40 kilometer, and my speed, I took 1 hour, so that means my speed was 40 kilometer per hour, right? Now that doesn't mean that throughout the journey I was going at 40 kilometer per hour. Maybe there's a signal, I stop it, there's the speed becomes 0, or maybe I'm at a particular time I get a free road, so I go at 100 kilometer per hour. So that means throughout the journey my speed will be different, but overall speed is 40, so that is average rate. But if I want to study the speed at a given particular amount of time, that is for a small time interval, I'll represent the rate or the speed by instantaneous thing. Okay, so the new term here is instantaneous rate. What is instantaneous rate? It just means that we are taking a smaller interval time, or to be more specific, write that at that particular moment. So that means the rate at that particular time, like for example at the 140th second or at the 12th second, what is the rate? Okay, I just want to know. So that can be represented by R, that is rate is equal to minus 1 upon A dA by dt is also equal to minus 1 upon B dB by dt, which is 1 upon C dC by dt, 1 upon D dt by dt. What is this? This is change in concentration of D. D represents small change. So this will be known as instantaneous rate. Okay, so if you represent it by delta, it is known as average rate, and if you represent by D, small d, it is known as instantaneous rate. Okay, for detail, for betterment of studying of a chemical reaction, we won't be proceeding with average. This is something which is not useful for us to study details in micro quantity. So for the chapter, we'll be proceeding more with the instantaneous rate, not with the average rate. So I hope this rate part is clear. So let us once again realize what is rate. Rate is just for a chemical reaction, rate will be given by change in concentration upon change in time. Now let us write down this equation for a particular reaction. Okay, let's say like we all know a very simple reaction for say a formation of NaCl. So we need 2Na plus Cl2 gives you 2NaCl. Okay, right. So if I want to write the same instantaneous rate, okay, or if the question says write the rate expression for this given reaction, how I'm going to write? I'll write R is equal to, since sodium and chlorine are reactant, right? So since sodium and chlorine are reactant, it will decrease, the concentration of the reactant will decrease, so we will be indicating them with negative sign, whereas for the concentration of NaCl it will be positive. We have to remember that here the negative sign indicates that the concentration is decreasing. We do not take the negative sign into consideration when you are solving the numerical. Okay, the concentration cannot be negative. Okay, it can only decrease. Right, so we proceed. For this reaction, R will be given by R is equal to minus 1 upon, just to commit coefficient is 2, so we divided by 2, 1 upon 2 T Na by dt. That is change in concentration of sodium upon change in time, can also be equal to, there is no coefficient, so it's 1 upon 1, that makes 1, minus d Cl2 by dt, which is also equal to 1 upon 2 d of NaCl by dt.